Good day and welcome to DepEd TV, a venue where we can be in one place virtually, even from different locations in reality. This is Teacher Rev, your grade 11 math teacher, your guide to an amazing and exciting math venture. In statistics, we do not simply determine the discrepancy of the individual data values about the mean of the population. We are also concerned to know how the means of the samples of the same size taken from the same group vary about the population mean. Today, be ready to explore mean of the variance of sampling distribution of the sample mean, as well as diving into defining sampling distribution of the sample mean for a normal population. We know that the mean of the population is equal to the sampling distribution of the sample mean. Let's recall the steps in solving the mean and variance of sampling distribution of the sample means by analyzing this problem. Mark is conducting a survey on grade 12 students of Nacionalismo High School. He found out that there are only few students who knew about the makers of the Philippine flag, consisting of 1, 2, 3, 4, and 5 senior high school students from 5 sections. Suppose that the sample size of 2 sections were drawn from this population. Describe the sampling distribution of the sample means. Our goal is to find the mean and variance of the sampling distribution of the sample means and to compare these values to the mean and variance of the population. The first step is to compute the mean of the population using the formula, which is the summation of x divided by the total number in the population. So we get the sum of the scores, which is 15, and the total number of the population is 5. Using the formula and substituting the values, we have in the numerator the sum, which is 15, and in the denominator 5. 15 over 5, which is equal to 3. So the mean of the population is equal to 3. Second is to compute the variance of the population using the formula. Let's create a table first. Get the difference of each value of x and 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0, and so on. Now, let's solve the square of the results obtained to be able to solve for the variance of the population. Quantity negative 2 squared is 4. Quantity negative 1 squared is 1. 0 squared is 0, and so on. For the summation in the formula, let's add all the squares. The sum of the last column is 10. This time, let's substitute the values that we have in the formula for the variance of the population. The numerator is 10 since the sum of the square of the difference is 10. So divide the sum by the frequency of the measurement to get the value of the population variance. Applying what we have in the formula, the variance of the population is equal to 2. The third step is to determine the number of possible samples of size using the combination formula, where uppercase N is the population size and lowercase n is the sample size. Since the sample size consists of 2 sections, then let's look at all possible combinations. In this case, the population is 5 and the sample is 2. Using the formula, we have 5 factorial in the numerator and 2 factorial times quantity 5 minus 2 factorial in the denominator. Thus, having 5 factorial over 2 factorial times 3 factorial, which is equal to 10. Or we can use our calculator. In this case, we key in the values. Based on the computation, there are 10 possible samples of size 2 that can be drawn. The fourth step is to list all possible samples and compute the corresponding means. The possible combinations are 1 and 2, which will have a mean of 1.5, 1 and 3, which will have a mean of 2.0, 1 and 4, which will have a mean of 2.5, and so on until 4 and 5, which will have a mean of 4.5. The fifth step is to construct a sampling distribution of the sample means. Based on the outcome of the previous step, the means are 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, and 4.5. Now for the number of occurrence. There is one sample each with a mean of 1.5, 2, 4, and 4.5. There are two samples each with a mean of 2.5, 3, and 3.5. Thus, the total frequency is 10. Now for the probability. The mean of 1.5 and 4.5 have a probability of 1 over 10. And the mean of 2.5, 3.0, and 4.5 have a probability of 1/5. The total probability is 1. The sixth step is to compute the mean of the sampling distribution of the sample means, using the given formula. Multiply each sample mean by the corresponding probability. The product of 1.5 and 1 over 10 is 0.15. Of 2 and 1 over 10 is 0.2. Of 2.5 and 1/5 is 0.5, and so on. If we add the results obtained in the product, the result will be 3. This means that the mean of the sampling distribution of the sample means is 3. The last step is to compute for the variance of the sampling distribution of the sample means using the formula. For the first row, the difference of the score, which is 1.5, and the mean of 3 is negative 1.5. Squaring it will have 2.25, and multiplying the result by the probability 1 over 10 would give 0.225. For the second row, the difference of the score, which is 2, and the mean of 3 is negative 1. Squaring it will have 1, and multiplying the result by the probability 1 over 10 would give 0.1. This process will go on until the last row, which is the 7th row. We get the difference of the score, which is 4.5, and the mean of 3 is 1.5. Squaring it will have 2.25, and multiplying the result by the probability 1 over 10 would give 0.225. So applying the formula, we substitute the value acquired. So the variance of the sampling distribution is 0.75. Note that the mean of the population is equal to the sampling distribution of the sample mean. This happens because all samples obtained of n size came from the same population. The variance of the population is greater than the variance of the sample means. Since a sample of n is less than the population n, then the data vary by a small amount as compared to the population. The example we answered showed the process in finding the mean and variance of the sampling distribution of the sample mean. The steps are: first, to compute the mean of the population, which is the summation of x divided by the total number in the population. You may also use the formula, where is the population size, sum of the given value of x, mean of the population. Second is to compute the variance of the population using the formula, where is the square of the difference between the sample mean and the population mean, is the population variance, the population size. The third step is to determine the number of possible samples of size using the combination formula, where is the population size, sample size. The fourth step is to list all possible samples and compute the corresponding means. The fifth step is to construct the sampling distribution of the sample means. The sixth step is to compute the mean of the sampling distribution of the sample means by multiplying each sample mean by the corresponding probability and adding the results obtained in the product. You may also use the given formula, where is the mean of the sampling distribution of the sample mean, is the sum of the products of the sample mean and the probability of the sample mean. The last step is to compute the variance of the sampling distribution of the sample means using the formula, where is the summation of the products of the probability of the sample mean and the square of the difference between the sample mean and the population mean, is the variance of the sampling distribution of the sample mean. Another formula would be the one shown, where is the square of the population mean, is the sum of the products of the sample mean and the probability of the sample mean. We may also separate the formula for the finite and infinite values as shown. The formula for finite population is shown, and the formula for infinite population is shown. Where is the population size? Is the sample size? Is the population variance? We may also want to compute the standard error of the mean by following the given formula. Where is the population size? Is the standard error of the mean? The things we need to consider in learning this lesson is to know the symbols and the appropriate formula being asked in a problem. Let's have another problem. A population of PWD learners in 5 schools in a certain municipality of Quezon Province are 9, 5, 6, 12, and 15. Suppose that 2 schools were selected as samples. Determine the mean and the variance of the sampling distribution of sample mean. First, solve for the mean of the population using the formula. Since the values of x are 9, 5, 6, 12, and 15, let's add all the values and divide by 5. Applying the formula, we have a mean of 9.4. Second is to compute the variance of the population. Since the mean is 9.4, we subtract each value of x by 9.4. Let me show you using the calculator. Let's use spreadsheet. And the results are shown on the second column, which are negative 4.4, negative 3.4, negative 0.4, 2.6, and 5.6. So to get the summation we need in our formula, we need to square the difference in column 2 using the calculator. Let's fill the formula. And the results are shown on the third column, which are 19.36, 11.56, 0.16, 6.76, and 31.36. Let's get the sum. And the sum is 69.2. Substituting what we have in the formula, we have 69.2 in the numerator and 5 in the denominator. Let's key in our calculator, 69.2 divided by 5. And the variance of the population is 13.84. The third step is to determine the number of possible samples of size n, which is 2. Let's key in our calculator. 5 factorial all over 2 factorial times the quantity 5 minus 2 factorial, which will result to 5 factorial over 2 factorial times 3 factorial. This will result to 10. The next is to list all possible samples and compute for their corresponding means. Let's use our calculator spreadsheet. So the samples are 5 and 6 with a mean of 5.5, 5 and 9 with a mean of 7, 5 and 12 with a mean of 8.5, and so on until 12 and 15 with a mean of 13.5. The fifth step is to construct the sampling distribution of the sample means. Let's list the sample mean and its corresponding frequencies. So the mean of 5.5, 7, 7.5, 8.5, 9, 10, 12, and 13.5 all appears once in the list, while only 10.5 appears twice, thus having a probability of 1/5, and the rest having a probability of 1/10. For the sixth step, compute the mean of the sampling distribution of the sample means using the given formula. We need to get the sum of the products of each sample mean and its probability. Now that we have the product, let's key in the values in our calculator. We have the products of 0.55, 0.7, 0.75, 0.85, 0.9, 1, 2.1, 1.2, and 1.35. Adding 0.55 plus 0.7 plus 0.85 plus 0.9 plus 1 plus 2.1 plus 1.2 plus 1.35, the answer would be 9.4. And for the last step, compute the variance of the sampling distribution of the sample mean using the given formula. To do that, let's get the difference of the sample mean and the mean of the population. Using the calculator, we acquired negative 3.9, negative 2.4, negative 1.9, negative 0.9, and so on for the difference. Now, let's use our calculator for the square of the difference. We acquired 15.21, 5.76, 3.61, and so on. For the product of the square and the probability, let's use our calculator. The results are 1.52, 0.58, 0.36, and so on. Now let's get the sum using the calculator. The sum of the product is 5.19. So the variance of the sampling distribution of the sample mean is 5.19. As stated from the previous lessons, one of the most important uses of statistics is to come up with a valid generalization of the population based on statistics of the sample. Since many samples can be chosen from the same population, each sample having its own statistics, the mean, variance, standard deviation, is quite different from those of other samples. The variation poses a problem regarding the reliability of the characteristics of the population estimated from one sample. However, if the samples are probability samples, the reliability of the results can be measured, and at the same time, the parameters can be estimated with a high degree of confidence. This time, let's try to define those statistical techniques designed to meet these ends. Let us have a little experiment. Let us try to determine whether the statements that I will give have a known or unknown population variance. I'll give you 5 seconds for this. Let us also identify the formula to be used to estimate the standard error of the mean by writing the symbol when the population variance is known and the symbol when the population variance is unknown. Are you ready? Let's start. Number 1. Because of inclusive education, learners with disabilities are also part of the normal students. Consider a population of the PWD learners consisting of 1, 2, 3, 4, and 5. Samples of size 2 are drawn from this population. Is the population variance known or unknown? If your answer is known, then your answer is correct. This is a population data. Although the value of the variance is not given, you can still determine the population mean and the population variance of the data using the given formulas, respectively. So this situation is an example of the sampling distribution when the variance is known. Since the population variance can be calculated, we can use the given formula for the computation of the standard error of the mean. Let's have our second example. Given the population mean of 15, the standard deviation of 6, and the sample of 16, is the population variance known or unknown? If your answer is unknown, then your answer is correct. The population variance is unknown. The given values are the population mean, the sample standard deviation, and the sample size. In this case, we can use the given formula for the standard error of the mean. What have you learned from this little experiment that we had? If your realization is that you learned that by analysis, you can easily find out if the given problem provides the value of the population variance or if the population variance is unknown. Also, we recognize that when the population variance is known, the standard deviation of the sampling distribution of the mean is computed using the formula. While the formula is used to estimate the standard error of the mean when the population variance is unknown. In the distribution of the sample mean for a normal population, there are two situations. First, when the population variance is known. The population has a mean, and variance of the distribution of the sample mean is normal and standard error of the mean, where sigma is the population standard deviation and n is the sample size. To determine the probability of a certain event, we can use the z distribution by transforming the mean of the sample data to an approximately normal variable z using the given relation. The distribution is best applied for large sample sizes. Now for the second situation, it is when the population variance is unknown. The standard error of the mean becomes this, where S is the point estimate of the population or the sample standard deviation, and N is the sample size. To estimate the population parameters, we can use the t-distribution by using the formula. Remember that as the sample size is very large, the standard deviation is almost indistinguishable from the population standard deviation, and therefore t and z distributions are essentially identical. Understanding the two situations will lead us to a more interesting discussion next week. But for now, let's have another activity. I will present the problem, then we'll do several tasks. First, we will supply the values of the given variable if there is any. Then, we will identify whether the situation provides an avenue for us to compute the value of the variance. In the case, we'll write known. Otherwise, we write unknown. Then we will also identify the formula to be used to estimate the standard error of the mean by writing the symbols when the population variance is known and when the population variance is unknown. I'll give you 5 seconds for every item. Let's start. First item. Consider a population consisting of 1, 2, 3, 4, 5, 8, 9, and 11. Samples of size 3 are drawn from this population. If your answer is the size of the population is 8 and the size of the sample is 3, then your answer is correct. Although the value of the variance is not given, you can still determine the population mean and the population variance of the data using the given formulas, respectively. So this situation is an example of sampling distribution when the variance is known. So if your answer is known, then your answer is correct. Since the population variance can be calculated, so if you tick on the first box, then your answer is correct. Second item, given the population mean of 12 and a sample standard deviation of 3 in a sample size of 125. We are given the sample size of 125, population mean of 12, and sample standard deviation of 3. If these are your answers, then you got it right. If your answer is unknown, then your answer is correct. The population variance is unknown. The given values are the population mean, which is 12, the sample standard deviation, which is 3, and the sample size, which is 125. In this case, we can use the given formula for the standard error of the mean. So if you tick on the second box, your answer is correct. I hope you did great on our last activity and is excited for more advanced learning on sampling distribution. Today had been a great learning experience. So, see you next week on another Math Venture with Teacher Red. Let me leave you with a quote. Statistics can be made to prove anything, even the truth. Bye!